Hamza Tahir and Adam Probst, the co-creators of ZenML and the co-founders of the company with the same name. Welcome to the Data Exchange Podcast.
Thank you for having us.
Hi.
All right. So ZenML, I went to the website of both the company and the project. So let me quote what you guys have on there. So build portable production ready MLOps pipelines. And then the other thing you have is an extensible open source MLOps framework for creating portable production ready MLOps pipelines. So clearly it's about MLOps. Clearly it's about production ready pipelines. So tell us about the origin story of ZenML. So how did ZenML come about?
Yes, sure. So Hamza and I met in 2017 in a program of the university, and we were trying to build a particular use case. So from that, we derived our first company, which was a predictive maintenance company for trucks or for commercial vehicles in general, because that was the industry I came before. Hamza was still a master's student, and then we met and built up that company in that particular use case, predictive maintenance. So we saw the need for that was the time when TensorFlow was starting at TFX. And we saw the need of some tooling to connect all the loose ends along the MLOps pipeline. And we then saw that the use case of MLOps was way more interesting, and you can serve so many more use cases than just predictive maintenance, that we flipped the company completely. So we stopped what we were doing before and concentrated on our the dog food, what we built anyhow already on for ourselves. And then we also decided to raise venture capital and open source it. And that was a very cool decision, because now we are growing the team and building hopefully cool products for the community.
So before we get into the exact feature set of ZenML, so who was or who is your target user or target persona?
It's machine learning teams. So we are bringing machine learning into production. So from the research phase into the production phase at scale. So this is why it doesn't really matter what vertical you are in, and it doesn't really matter how big your company is or the holding. It's more focusing like data science teams or machine learning teams or MLOps teams. They are named differently all over, but it's all kind of just seeing the problem from the other direction.
But is it the teams that are already quite serious about productionizing machine learning? So in other words, if I'm still just kind of playing around with a model or a bunch of models.
So the way we think about it is in terms of MLOps maturity. So there's different ways of defining maturity. I know Google has a way, Microsoft has a way, we have our own mixture of those things, but essentially what you say is correct. So if you're at the point of transitioning from a notebook script-based setting to a more orchestrated workflow, which is a bit more production ready, then that is the point where we generally see a lot of people seeing interest in ZenML. So if you're really just starting out with your MLOps stack, your MLOps pipeline, then this is where we usually see a lot of people coming into ZenML, but that is not to say that we don't see people further down the line, because as we'll get into in a second, I guess, when we talk about ZenML, like ZenML connects a lot of the pieces of the MLOps pipeline. So if you have two pieces already in place and you want a third, then you might also find ZenML attractive.
So where does ZenML begin? So in other words, if I'm still kind of ingesting data, I'm still preparing, cleaning data. I'm assuming that's not where ZenML begins, right?
It actually could begin that point, because the way, so this is a bit of a new way of thinking about things. So maybe we can linger on it for a while. So classically in the MLOps world or the ML world, we've seen two phases or even three, where there's a handover from the data science cleaning, experimenting part to the productionization part. And actually, to be honest, we've seen a lot of pain in that transition. And you must have talked to hundreds of people who have faced that pain themselves, and we face that pain. So the way we think about things, and ideally the way that it should work, is that your experimentation and scratchpad pipeline should be the beginnings of a production system, and it should be portable across different systems. So you have, in other words, you have different requirements in experimentation. You want to get started quickly. You don't care about orchestration. You don't care about drift. You don't care about deployment. But your code base should be the beginning, the root, which you can then augment different things in production and then port it to different production systems. So we actually encourage people to start writing pipelines as experiments from the beginning. So if you're just playing around, you should be writing pipelines as data science code. And actually, that's one of the things that we encourage.
But you folks don't necessarily own specific stages in the pipeline, right? So when I'm doing experimentation, I could be using ML flow. Yes. When I'm doing deployment, I could be using Reserve or something else. But exactly. So in essence, are you guys basically orchestration?
That's a good question. I mean, we like to differentiate between orchestration as some people might define it. So in some ways we are orchestrating, right?
So let me define, orchestration for me. An orchestration system has the following components, I guess, like a metadata store, a scheduler, an executor, right?
Yeah.
And then dashboards for monitoring and observability.
Exactly.
So that's a classic orchestration system.
Yeah, and that's exactly what we're not. So the reason what we like to be differentiated from the Airflows or the Prefects or the Flights or the Daxters is because those tools are awesome at what they do. They orchestrate workloads and they have those components that are, and for us, that wasn't the problem that we were trying to solve. So like ZenML pipelines are able to be orchestrated in multiple orchestration systems. So you could orchestrate ZenML pipelines on Kubeflow, on Flight, on Daxter potentially, or other.
So ZenML is kind of a framework that imposes some discipline in terms of how I stitch together these pipelines.
There you go. Yeah. So that's the layer we want to operate on. We want to.
But then let me ask you this, Hamza. So the orchestration tools do that too, to some extent, right? So they tell me, here's how I connect this component to this component.
They do that but they are hamstrung by their use case. So they are like, generally orchestration tools are agnostic to the use case which they're orchestrating. And with ZenML, we know what use case we're orchestrating. We want to enable continuous training, continuous deployment.
Oh, so there you go. So see, Adam, he admitted orchestrating, huh?
No. So I think what the key difference here, so I mean, we don't need to get lost in the weeds of the definition.
Right? So basically you are optimized for pipelines that are ML in nature.
ML in nature, yes.
But then, but ML pipelines, as we discussed earlier, depending on your level of maturity, have different characteristics, right? So it could be like a one-off ML model, right? So or a model that's already deployed, or I'm aspiring to deploy this model to production is very different from I'm aspiring to build this model to learn something about the data.
Yeah, exactly. Right. So the thing is, that's exactly the value that you might think where ZenML would shine. So let's say you're at a different stage of a project. Let's say you're just experimenting, and at that stage, like ZenML would be presented to you as a non-orchestrated tool that helps you track your experiments and metadata in a reproducible way, connecting stuff like ML flow and DVC together. So that could be a constellation of an MLOps stack that could be useful for that sort of team. For another sort of team that has an orchestrator in place, let's say they're using the modern data stack with Airflow, they might have different requirements. They might want to orchestrate, they might want to transition from that level 0 setting to a level 1 setting where they want to introduce Airflow, and then suddenly they want to start detecting drift with great expectations, and they want to deploy it using Seldon, and they want to run it on Airflow, as I said. So in that way, ZenML would be presented more as a higher level transition between orchestration systems. So that's why I think the value that we provide is a bit on top of all these tools and binding them together and making the transition easier. I think like perhaps we could look at it from that angle, and that makes it very powerful.
Let me push back.
Go ahead.
But doesn't that add some complexity to my if I'm a data platform person, right? So you're now telling me besides an orchestration tool, I need to add this other piece that sits above orchestration. So I would only do that if I were super, super deep into ML and I have a lot of models and I'm serious, right? So I'm, as you described earlier, I'm really way down the maturity line.
Not necessarily. So I would push back on that. So there's different ways of looking at that, right? So like nowadays in the industry, what we're doing is we are seeing the emergence of so-called MLOps teams, MLOps, internal MLOps platform. And insofar as we're concerned, these are people doing the same thing that I described. They are making the transition easier. They're visualizing things. They are making the standardized workflows that are then portable and connecting different open source tools together. And that thing you have to do anyway. So we've talked to teams who have built it on their own. I mean, you might want to call this an MLOps platform.
As you were talking there, I think I kind of understand what you guys are trying to do. Have you guys heard of Ray Air?
No.
So Ray AI runtime, but this lives in the Ray world. So Ray is this kind of very powerful general distributed computing platform, right? So which you can use to scale any kind of Python or ML workload. But it also comes with libraries. So there's a library for training called RayTrain. There's a library for tuning, RayTune, serving, RayServe, and a very simple data processing library called Ray Datasets. But there's other data processing things that integrate with Ray. And also Ray integrates with other libraries as well, like Hugging Face and Spacey and stuff like that. So Ray Air allows you to kind of piece together all of these things seamlessly, right? So in that context, in the Ray context. So in your case, what you're saying is I can piece together ML flow with Optuna, with Seldon, kind of, and minimize the friction.
Yeah, exactly.
Between them, using some sort of API that ZenML provides, right?
And let's use our home ground German advantage to push home a visualization of that. So we consider ourselves sort of the Autobahn that connects the tools, or the highway that connects the tools together. So you don't have to build your own highway.
So in the absence of ZenML, I would have to use an orchestration tool to do all of this for me. And I can do that, but that would be a little more complicated for most people.
Sure. And still quite manual with a lot of glue code. So this is what we also faced in the very beginning.
So does this, Adam, does this mean that what you folks have described in terms of lowering friction, this works only for certain libraries that you folks have gone out of your way to integrate with?
Yes, and we built it very open that you can still keep on integrating yourself. So we have also contributors, external contributors, which are building what they need and connect it to ZenML. So we kind of trying to get to the critical mass where people say, oh, cool, I also want to integrate into ZenML to get less friction.
So from code perspective, so I built the model. Now I'm using ML Flow. Now I'm about to deploy it to production. So how much stitching code? How complicated is the code to stitch all of these together? And also add logic for basically similar to what an orchestration tool will do, which is basically wait for this thing to finish, then start this, right? So if this thing fails, wait, let it retry, and then.
Yeah, but so I give that to you. But first of all, you have to see how many people are touching this. Like, how often is the responsibility transferred within that whole process? Does the person have the right skill set to go through the whole machine learning pipeline, or are there 2 different teams or 3 different teams which just throw over the fence what they had and then keep on working on it? So we have a lot of friction in these handover points, and there is if you find somebody who can start from the very beginning and go to deployment and retraining, that's almost a unicorn person. So you don't find that.
But that's as you point out, that's an artifact, and that's because our tools are bad. Right.
Exactly.
So not the reason you need a unicorn person is the tools are hard to use, right?
Yeah.
But by the way, so one of the things Hamza that as I was describing, so one of the things that an orchestrator does for you is when you have a sequence of these tasks, if one task fails, it takes care of retrying and all of these things, right? So
so absolutely. So like ZenML presents the orchestrator layer in a similar fashion. So you could do those things.
So ZenML also you will still need an orchestrator, but ZenML makes interacting with the orchestrator simpler. Is that?
Yes, and we have. So let me put it this way. So you have, like, let's say, go back to your use case. So you said you have an ML Flow model. You track it with ML Flow. Now you want to deploy it, and you want to do all those things together. So what you would do with ZenML is you would, we have these different interfaces when you write your code, how to include your experiment tracker. So let's say your experiment tracker is ML Flow, you would put that as a decorator at the top of your function. And then like downstream, you could import a deployment step that could deploy that model on the deployment target of your choice, let's say Selden or Kserve, or even ML Flow itself. And then the transition between those 2 tools would happen through our notion of what an artifact store and a metadata store is. So we do have those notions. They're still open, so you can see them. They're just MySQL and blob storage at the end. But we sort of interface those tools together in a more elegant way so that you can just plug and play other tools as well. And this really bears to fruition when you start implementing use cases like continuous deployment, or when you have a data annotation tool in your chain and you want to version data and you want to pull data directly from it. So an orchestration system could potentially not take a stance on how to link to a data annotation tool or how to link to a model deployment tool, because it doesn't really care what's being run on it. And with ZenML, we can take that next step, make the pipeline aware of those things, and therefore then enable things like pulling down a service, springing up a new service for deployment, or pulling the latest data from a data annotation tool, so on and so forth.
So let me so maybe one way to help this make this more concrete for the audience is let's take a couple of case studies and use cases where people had some tooling in place, maybe even an orchestration tool, and you folks came in, and what was the difference before and after?
Well, yeah, that's a really cool way to do it. So let's take our canonical, I would say one of the most popular sets of things, right? So let's say you're running a deployment process and a training process, and you're using pick an orchestrator, let's say Airflow. So you're running orchestrating on Airflow, and then you have to track the things that are running on Airflow with MLflow and the model registry as well. And then you have some pre-processing logic that runs in the pipeline that then needs to be ported over to a deployment mechanism like Selden or KServe. And that process is disjointed. So the tools don't know about each other. So currently what you're doing is you're running your pipeline in a continuous way, you're logging somewhere, tracking things in a different way. And then when you're deploying, you're doing things in a different way. And when you're running your experiments, you're doing things in a different way with the MLflow UI. And that's
there's a lot of APIs and context switching.
Exactly.
Right?
There's a lot of context switching, and not everybody would know how to use one API. For example, if something fails, a data scientist might not know what happened in Airflow. They might just know what happened in MLflow. So, and now with ZenML, what they do is they write those pipelines with ZenML code. They follow the APIs of ZenML. So they include MLflow into their pipelines with our decorator. And they include the Selden deployment with our notion of deployment. And suddenly you have one API. So you have the ZenML API that you can then fetch and then trace back and reproduce things and go to different tools if you need to debug. And you can also have primitives like models, served models. So you have a CLI which lists the served models. We have the CLI which lists some experiments. So you could open up UIs of MLflow automatically through our tool. So it glues everything together in a way that you don't have to do it. And then if you do run into like some sort of problem where, okay, there's one feature of one tool that I need, then you could go into our API and create a pull request. So this sort of system has to be open source, right? So
so this is all well and good when things are going well, right? Yeah. So as you know, Hamza, in ML, things are guaranteed to not go well. Not go well, right? So now you're in a scenario where you have potentially multiple distributed computing frameworks, right? So each with its own notion of fault tolerance. Something could go wrong, and so I guess you folks will have to handle if one of the systems starts failing. And then the other thing is at some point in the ML ops process, so ops to me has a few key components, right? So there's monitoring and observability, which includes alerts. Sure. There's root cause analysis, right? Is another important thing with ops. So, and obviously the main goal with ops is to minimize your time to recovery, because you assume that things will fail, but you want to be able to diagnose as quickly as possible and fix as quickly as possible. And as some of our listeners will know, in ML, when things go wrong, almost always it's a pipeline somewhere, right? Yeah. It could be like a data pipeline downstream. So does ZenML help me with any of these things?
Absolutely. So that's one of the main use cases ZenML would come in very useful. Because what ZenML is doing is it's tracking all the configuration of all your infrastructure systems in what we call in ZenML a stack. So you have, like, you could have your secrets there, you could have a lot of things with ZenML's API. And therefore, and like ZenML also sort of at a high level orchestrates, as you would say, the different way data and code flows through the different systems. So let's say something went wrong with one system. Let's say a pipeline failed somewhere. So the first thing you might want to do is you might want to go through ZenML and see what happened, because you were to be presented with logs through ZenML. So you would be able to see, okay, what went wrong from the orchestration system. So let's say something bugged out with your logging of.
By the way, most of the time it's a data pipeline, even before you start training, right? So.
Yeah, exactly. So you would have in ZenML stored what data, like slice was it on. If it's stored in DBC or some other system, you would have the precise, link to it. If you have an experiment track in MLflow, you would have the ID of it.
Or I guess from your website, you guys also integrate with some of these data quality tools, right?
Yes, and especially if you talk about in terms of data quality, there's two basic aspects to it. I think one is like monitoring, like data validation tools. So something like great expectation or deep checks. And there's like drift detection, which is more harder, I would say harder to do, but there are great tools out there like evidently or like NannyML, which is coming up, which are trying to solve those problems. So within ZenML, you could, like one thing that people really like about ZenML is that it gives them a clear window on how to use these tools without going through all their documentation and stuff. So you could just plug it in quickly and see what happens. And the reports and the things that are generated from these tools, they're usually, HTML files or like JSON reports. Those are also persisted in the notion of a ZenML artifact store, and you have a complete lineage over it. So you could, for example, go to the latest great expectations report through ZenML, and you could say, okay, so the reason the pipeline failed is because there was a null value which caused the expectation to fail. So that like triggered the failure.
It sounds like the vision is kind of like the equivalent of the modern data stack, which is basically I have the and by the way, modern data stack I have problems with at some level, right? Which is the following: modern data stack means that I have access to, in many ways, best of breed solutions at every part of my stack.
Yeah.
Which means, I have an exponential number of combinatorial problem, right? I have to choose I have many things to choose from in each level of my stack. But then if I can do that, then I'm in good shape, right? So in your case, what you're kind of describing is I can choose many different tools at each stage of the ML pipeline. ZenML makes it simpler to stitch them together.
Yeah.
The modern ML stack.
And now you're going to talk about bundling and unbundling, and we're going to get into
which also includes the orchestration tool. I can pick an orchestration tool, and ZenML will make it easy. And so that's one thing, right? So there's that kind of notion of being able to take the best of breed solutions.
Yeah.
And then secondly, there's also the notion of I can do this from the beginning. So when I'm still on my laptop, kind of just playing around, if I use ZenML at that point, then a lot of what I'm doing carries over as I get more and more serious towards deployment and productionizing.
There you go.
And what's also cool, Ben, is that you can delay all your decisions. If you're not happy with a tool, then you can just swap it out like a Lego brick. And there's no lock-in effect in the end, and you can really see what fits best.
Yeah,
I see. And so then, really though, I really should start using ZenML. In your minds, I should really start using ZenML even when I'm still kind of, at the really early stages. I'm still playing around with the data, doing exploratory data analysis. I'm already kind of in the ZenML world there, and then I start doing some training and then do some experiment tracking.
Yeah.
Right.
Yeah.
So is that kind of what your vision is? I'm kind of ZenML is accompanying me in every stage of my workflow.
Yeah, I mean it's like standardization, right? So at what point of your coding development do you standardize? There are some practitioners who say, okay, don't take that overhead at the start. We'll see, and then we'll start, do it later. And some say the earlier you do it, the better. And for us, I mean, theoretically, we have many categories of users, but I would say there are two categories. So one category is using ZenML as an exploratory vehicle of the MLOps stack. So they're at the start and they're exploring other tools through ZenML. And at that point, they start adopting ZenML at the very start. And I think that's very helpful for them because they incur a lot less technical debt. And the other sorts of users are people who have already built a ZenML internally in a sort of a Frankenstein way. And they are really struggling to maintain it. And now they just want to swap out parts of it. So then they do it later. But, in essence, you don't really, the way we designed it, you don't really need to change a lot of things in your code in order to write a ZenML pipeline. So you could start at that point.
So in the ZenML website, I forget, I think it's in the company website, not the GitHub page. You guys have a diagram where you have examples of tools that someone can use. So are those, the tools in that diagram, are those the ones that are quote unquote blessed, much more integrated with ZenML? Or what is, so if I have, so let's say I have a brand new library, right? So that, let's say in time series. So how do I get that into the ZenML world?
Yeah, good question. And I've had to answer that question a few times with some tooling providers as well. So I think we should have some clear documentation on it. So like right now we're 8 months into the journey. So there's a bit of missing gaps online, but I would say that the way you would do it is that we have this notion of abstractions across the pipeline. So we have an abstraction for an orchestrator. We have an abstraction for an experiment tracker.
But in practice, Hamza, let's say I'm just a user of a time series library. Someone else wrote it. Now I want to start using this in the context of ZenML. How much work do I have to do?
Not at all. It's like, so we always thought of ourselves as long as the abstraction is there, we give you the tools, and we actually encourage this to write your own classes that encapsulate that tool. So we think of ourselves as a Ruby on Rails or whatever you want, like from the web development work, right? So you have these React components and then you override them and you add your own custom logic. So in ZenML, for example, you have a stack, and stacks are made of stack components. And you can literally register, you can do ZenML alerter, ZenML drift detector, ZenML time series, whatever, register, and then point to your class and give the parameters. And ZenML will then understand that the class that you wrote is a model deployment class. It's an orchestrator class or whatever, and behave.
And then, so then the benefit for me, if I do this for each of the tools I'm using, is I have kind of, now they start talking to each other more seamlessly.
Exactly.
And maybe I have a unified view for monitoring and alerts. Is that?
Yes, that would be part of it, but not just that. So you have this, like the basic problem of machine learning is also data, right? So like how does data flow from one system to the other? And that would also be tracked and be reproducible. And then another thing, of course, is environments and dependencies. And how do you manage that? And how do you make your code portable across different orchestration systems? So ZenML also helps with that.
Right. So if I don't have an orchestration system, is there an orchestration system that comes with ZenML?
Now you're asking the controversial questions. So are you at some point going to launch an orchestrator? Is that the question?
Yeah. Well, let's say I'm kind of at that point where, okay, so I've used a bunch of orchestration systems, and this ZenML seems to be good for me.
Yeah.
Is there a way for me to just use ZenML?
Yes, there is a way for you to use ZenML. So ZenML comes built in with many very basic orchestrators that you could just use off the bat. So for example, the Kubernetes orchestrator is an orchestrator that lets you run Kubernetes batch jobs as ZenML steps. And that you just need a Kubernetes cluster for. You don't need a kubeflow or a flight installed.
Or Argo.
Well, Argo we don't have a standard yet, but again, I think our problem is we want to get to a critical mass of tools, and then we want to flip it.
Yeah. I mean, I think the challenge for you guys is kind of this exponential number of tools, right?
Yes.
Yeah.
So as I described early, as I revealed early, I'm an advisor to Databricks. So when they first pitched me MLflow many years ago, I loved it, but I thought that this is going to be hard because there's so many ML libraries, right?
Yeah.
But in many ways, they've done it, but that's a much more limited problem because they just have to deal with these ML libraries. You guys have to deal with every stage of the pipeline, right? Including experiment tracking, right? So.
Yeah, but the cool thing is, so like first of all, we believe that this problem needs to be solved in order for the ML industry to move forward anyway, because we've talked to
I have a pushback to that, but go ahead. Yeah.
Okay. So your team bundling, I guess. And the other thing that we think is that, like the way we approach it from an open source perspective, right? So we have an open roadmap, and obviously we cannot do everything at once. So we have what we've done is the most logical approach is we know that there are some tools that are just way more popular than others, so we just start with those. So MLflow is a no-brainer, right? Like something like Airflow as an orchestration tool is a no-brainer.
Yeah. In that space where MLflow is, the top two most used tools in that stage of the pipeline are probably MLflow and TensorBoard.
TensorBoard, yeah, or weights and biases, I guess, is a close.
Much lower. Yeah.
Yeah.
I have a post coming out tomorrow. I measure the usage of all these tools.
Yeah. I would be super interested to see those because I think that's something we've also researched a lot, talking to many teams. And it's not like it's not an endless amount. I mean, it seems like thousands of tools, but it's a long tail of tools. I think.
Yeah.
That's how.
Yeah. So here's my pushback, right? So
good.
Companies who are, let's say enterprise level companies, right? So they may actually build so what you're describing is great for people like us who like to build platforms, right? But most companies might end up just buying a platform, right? So think of a company that uses Databricks, right? So Databricks will do your lakehouse, data processing, ETL, ML, experimentation analysis, all the way to deploy. Done. Because I'm just using, I'm a user, right? But if I have to build a platform from scratch, yes, maybe I will need something like ZenML. But, when you get to like the largest companies in the world, chances are they may have a mix of, some teams will use the internal ML platform. But, now you're talking about, I have to hire data platform people away from tech companies to work for me to do this kind of thing, right? Or I can just use a platform from someone else, from a SaaS provider or something, right? So anyway,
is that I do have a pushback on that, but you can move on if it gets too pedantic.
So what?
So I have a pushback to your pushback, or a question to you. So
sure.
Do you think that the ultimate solution would be to get a SageMaker or a Databricks to be the one platform? Because I think one of the things that we've seen is
no, but it's I don't think it is, but it might be the quickest way for you to, when you're getting started, right? Because you don't have to build a platform. I'm just a team. I don't have a platform team. I don't have a ML or data platform team yet.
Sure.
But I want to try some ML, some simple recommenders. Then I could move faster there.
So what if you could use a system that could then run on Databricks? So like ZenML, for example, let's say you could run all of it on Databricks because Databricks is supported or AWS is supported, and then you have the flexibility to switch as well.
So I think part of the challenge here is that the reality is you have a funnel, right? So first I have to gather data, then I have to store and analyze simple analysis of data like BI. Then I can do some analytics, simple forecasting. Then I'll do some ML. Then I'm doing some deep learning, but I'm gonna start buying tools or investing in tools for ML when I have a lot of ML and deep learning already, right? But reality is most companies are probably still in the data warehouse BI stage, right? So, but they will eventually. It's just a question of timing and how they get there, right? So what's the?
So, but you also have the problem. This is why we are pointing out that we are a framework, not a platform. So because a platform is opinionated, you have a limited set of tools which you can integrate, and then in the end you have a lock-in because you have so many dependencies. And also quite expensive, or some when it flips and the technical debt is, or let's say everything what you built so far is dependent on this one and only platform. And what we also see is that many people who are about to get into that step to have a login, they would better come to ZenML and try to
but lock-in implies you don't have lock-in if the file formats are open, for example, right? So you can use whatever tool you can use whatever tool you want at that point, right?
Yeah, but if you have an ML flow integration or a deployment mechanism that doesn't update its APIs until next quarter, and you want to get your model deployed with the latest version, then it doesn't work. So I think there's lots of levels of where lock-in is painful for ML teams, and you cannot just open up an issue and expect that you can be as fast as you would like to be. Especially,
I agree for advanced teams.
Yeah, let's see how many advanced teams come out then. I mean,
well, I'm talking about 90% of the teams, right? So.
Yeah. All right,
really looking forward.
So anyway, so what's on the roadmap for ZenML? What's the near-term roadmap?
So it's open. So you could see.
So is it so at the high level? Is it mostly let's get more and more of this best of breed tools working with ZenML, or what are the priorities?
Yeah. So the next priority for us is that we need to get a critical mass of tools that work together that show the value of doing this thing. So as you rightly pointed out, when initially you encounter something, you might think it's an overhead, you might think it's not necessary, you might think, why not just put this tool and this tool together and make it work? So that's one of the arguments we have to defeat by making these things simple and accessible. And to be honest, Ben, most of the work we're doing is sort of educating also, like people on different stacks and what the stack components are and why you might need an experiment tracker, why you might need an orchestrator, why you might need a drift detection tool, and when those things are necessary, and then eventually how to use them. So priority number one is to have abstractions across the MLOps pipeline end to end, from, let's say, feature stores or data annotation tools, which
So you have, at this point though, Hamza, you have based on the diagram I described earlier, you have integrations with tools at every stage of the pipeline. So what you're describing is it to expand the footprint to even earlier in the pipeline, or to increase, is it breadth or depth?
We have some part of the breadth which we need to cover. So data annotation tools are still something we don't have, so we're just releasing them in the next releases. We also have one big thing, which is distributed processing, which is a very common thing.
Yeah,
and
Ray. Integrate with Ray. I can introduce you to the Ray team. Yeah.
It's so funny that you say that. We had a few weeks ago, we have these internal thing we call Zen shares. And in these Zen shares, one of our two team members presents something of interest. And last time it was Ray, and one of our team members was such fanboying over Ray.
Yeah, I have. I'll introduce you to the person who leads the open source team.
Okay, that's cool. Yeah, I mean, NEScale and Ray we're big fans of. So we don't need to be convinced. We should get the Ray integration done soon. Whether it's Ray Serve, whether it's Ray Tune, whether it's Ray.
So by the way, it's very interesting you mentioned data annotation, because there's a big trend in ML that our listeners have heard me talk about, which is basically, at this point in certain areas in ML, we have a lot of good models that we can use off the shelf. So take, for example, NLP or computer vision, right? So you can go to a model hub, like, for example, Hugging Face has thousands of models you can choose from, right? So off the shelf, they will work good enough, but maybe not as accurate as you will want if you were serious about using it in an application. The accuracy is great, but not perfect. Because think about NLP is very subject and application specific, right? So this model is trained in internet data, but you want to apply it to some very specific area in medicine, right? So obviously not going to work as accurately as you want. So what we found in our surveys of teams is that the tool that they really want to have is a tool that will let them tune these models for their domain. And what does tuning mean in practice? That means data annotation, right? So, and then a little bit of tuning and transfer learning, and then iterate, do some more annotation. So basically, training models from scratch, maybe you don't need to do that anymore because there's a lot of off-the-shelf models you can start with, but you need a lot more tools for tuning and transfer learning and data annotation. So yeah, it's I think that's a great idea that you guys should integrate.
Ben, one of the big use cases we want to enable, the annotation tools are so amazing. Like you have so many.
So for our listeners, Hamza, so can you rattle off a couple of data annotation tools, 2 or 3?
Label Box, Label Studio, Rubrics. There are many open source.
Are these all specific to computer vision? Are they?
So some are agnostic, some are more catered towards vision, some are more towards NLP. I'm blanking on the name. The one from Prodigy.
Spacey guys.
Spacey, like I think those guys are doing just a fantastic job in it. The only thing is it's not open source, but it's sort of very open in some ways.
So ZenML, if the tool I want to integrate with or to ZenML to use inside ZenML is not open source, how does that work?
You could do that, but to be honest, it's a bit of a less cooler experience. But I mean, you could have, the classic example is the Databricks of the world or the SageMakers of the world. So, right, you can run ZenML steps on SageMaker.
Or like you said, if I have a data annotation tool that's not open source.
Yeah, but those data annotation tools by definition have APIs because they know that at some point data needs to be exported and run through some training systems. So unless you have a data annotation tool that also takes an opinion on training and deploying, there are not so many of those. But
luckily, Hamza, most of the tools at this point have some sort of API, and many of them talk open file formats.
Yeah, exactly.
Right.
Yeah, and that's what we've seen so far. So the tools that we're integrating with right now, so let's say Rubrics or Label Studio, those all have open APIs, and they expect to be consumed from downstream. So we're just building integrations. And the problem is that this process classically has been so neglected in the MLOps teams because there's this handover from the annotation, then you have the training pipeline, and that gets handed over to the production team or the data team that then productionizes. So just having a complete story with all the tools linked together is something we want to get to in a couple of weeks, and hopefully you'll see in the next releases we'll have the annotation story up.
And so you talked about continuous integration and continuous deployment. How many people are really at that level of maturity for ML?
It's not like they don't want to do it, right? It's just that they don't know how to do it. So it's not, it's too scary even to think about it. But one of the things.
By the way, Hamza, as I was asking that question, actually the bigger meta topic in my mind is for the last few years, I think there's been this huge desire to inject software engineering rigor into ML, right? So in other words, ML is ultimately software, but it's a complex software that relies on data, pipelines, so on and so forth. So how do I do unit testing? How do I do integration testing? And all these things. So I mean, it seems like ZenML, particularly since it unifies different tools together, might provide a basis for this aspiration for many teams, which is how do I become more rigorous from a software engineering perspective, right?
Absolutely correct. I think that was one of the big things going into this, talking to now hundreds of teams. I mean, you'd be surprised that might be their main problem. So their main problem, like one of the teams told me, I could just solve this if all my data scientists wrote the right object-oriented sort of code. And I said, well, it's not so. Yes, that's maybe a big desire, but it's hard to enforce. So, and we took a lot of inspiration from the, like other domains like web development, where we had higher level abstractions of things. I mean, like just look at what happened in web development. When I was doing web development 10 years ago, it was PHP, CodeIgniter, all the stuff you had to write, WordPress. And now if I looked into it, it's like Next.js, Gatsby, you have all these things which make it so much easier. And therefore, thousands of people, like my own brother, for example, he's not a classically trained software engineer, but he's a lead front-end engineer somewhere now. And the reason is that these tools made software engineering rigor accessible. So it made it more accessible, it made it easier to consume, and therefore to implement for many people who aren't classically trained as software engineers, because they knew, okay, this is how to structure the code now. There's a guiding hand which holds your hand through that process. And with ZenML, we definitely hope to achieve that effect.
So how do people stay up to date with what's happening with ZenML? Are there major events coming up? Is there like a webinar or I'm sure I can point to the Twitter, the GitHub repo and all the standard social stuff, but are there major things coming up?
So we have a regular meeting, which is it's a community hour every Wednesday. We are quite active on Slack, and not just us, but also the community with each other. That's really amazing. And we also have a newsletter, but that's coming out every 4 weeks or something. So that might be, the cadence is too long for being really up to date.
So at some point, I assume you folks will plan like a ZenML get together of users, right?
Yeah, sure. Every week that happens. So at 5 p.m. CET.
No, an in person.
Oh yeah, in person. Yeah. We have to think post Corona now. So yes.
Yeah. Will you drop by?
Yeah. All right. So and with that, thank you, Adam and Hamza.
Yeah.